Hi, this is Calvin Cox. It is July 14, the year is 2014. It's Monday evening and it's 6:51 p.m. What I wanted to talk about was barometric pressure, and I'm trying to determine exactly with barometric pressure if in fact the barometric meters are adjusted the right way. Now you might be thinking, how in the world can anybody question whether barometric pressure gauge is actually set up the right way or adjusted correctly? And actually I'm beginning to have some questions about that because of just some basic scientific facts. And I'll tell you exactly what they are right now. Except one second, I gotta get something. Okay, now, what I've read so far, you get these science books and you look at them and they're pretty straightforward what they say, except for when it comes to a completely thorough diagram of a barometric pressure gauge. And there's several different barometric pressure type gauges. But the point is, they say that atmospheric pressure, if you take like a column of air, let's say a square inch or a square foot, and you go all the way up to the very upper atmosphere, all of the weight of that air pushing down, basically all the mass pushing down, is what atmospheric pressure is for like one cylinder size, either this big or this big, going all the way up. And I think that's 14 psi, pounds per square inch, roughly. Not exact, but it's fairly close. So my thinking is two different things. If it's a sunny, dry day, okay, and that column goes all the way up to the very, very top of the upper reaches of the atmosphere, there's not much there because it's sunny and it's dry, and so there's not much there as far as something voluminous to weigh down on it, okay? So to me, that wouldn't weigh as much as, in my thinking, as for instance, a rainstorm is happening and you were to take a column of air all the way up and you go up through the rain clouds and up through the thunderhead, and there's a lot of moisture, a lot of water, and water has a lot of weight to it, and the air is saturated with moisture, so it's going to weigh more. In my thinking, I think that makes sense. So if you took one column of a rainstorm, wet air that has more weight to it, in theory, my thinking, it should weigh more, okay? And therefore it would have higher pressure. And a sunny day, there's less there. The moisture is all gone away and it's just warm air that's expanded, so there's less there. So that, I'm thinking, would weigh less. So, but you hear the totally opposite. You hear that that warm, dry air is a high pressure system, and that raining outside is a low pressure system. Okay? So how could something that would have measurably more mass in like a moist column of water be called low pressure? And something that has measurably less, okay, water, it's raining, low pressure, it has more measurable mass with the moisture in the air. Sunny day, the air is warmed, it's thinned out, there's not much of anything there. It has less measurable mass, but it's called high pressure. Okay. Now, if you fill this bottle up with air, okay, I have water in it right now. Let's just say it's filled only with air. And I set it on the windowsill and I close it tight, set it on the windowsill, and the sun beats down on it, the air inside of it's going to get warm and it's going to expand, and the pressure is going to increase. Okay? But the atmosphere is not that way. The atmosphere is not in a bottle that's confined. The atmosphere is free to move all around. Okay? So, when they say high pressure, if it's a sunny day, it's warm out, you know, there's no rain, and high pressure, I have a hard time thinking high pressure because it's not in a closed container. It's in an open atmosphere that can, you know, change all the time. So I have a little bit of a hard time understanding that. Hold on. The other thing I was thinking, how in the world could that be wrong, possibly? And I'll draw you two examples. Let's have a scale, needle, pointer, pivot, the arm to the sensor, inlet, here. Now I'm not gonna give up on this till I get my answer. And I've been looking everywhere. I downloaded a ton of information at the library the other day, and I was reading through it trying to find a few nuggets to point me in the right way or not, and I really couldn't find them. And I even printed out some diagrams of barometers, and they were not really that helpful because they don't show when the high or low air pressure enters into the sensing device. They don't show super in-depth, completely accurate as it would be made in a factory. You know, when somebody draws a diagram of something, it could be made different in the factory unless it's a factory schematic, which I don't think they're really supplying to me for what I was trying to find on Google, on the internet. So my point is this. This is the only way I know how to say it. Okay. This right here, both these are two instances of the same thing. The only instance is, okay, this right here is a pivot point of the needle, and that's pivot point of the needle. The only difference is the sensing arm that pulls on the needle is below the pivot point here or above the pivot point in this case. Okay, now, if you apply, let's say that pressure is applied this way, in this picture, okay? However, the atmosphere, high or low, the pressure is going to be applied going this way, okay? Same thing here. Okay, now, if pressure is applied this way, okay, above the pivot point of the needle is going to go this way, okay? The scale, so it's going to go this way, okay? Let's say the scale is this, 0, 1, 2, 3. Okay, 0, 1, 2, 3. Okay? But if the pressure is applied below the pivot point, it's going to push this way. Okay? In this case, it's going to pivot here and the needle is going to go that way. Okay, so the two differences very simply are, if it all depends on where the push is above or below the pivot point on the needle. Okay, now, so far I have no correct indicator or have been able to find something that says definitively 100% that these barometric pressure gauges are made a set certain way. Have not been able to find it. It is very possible that when barometric pressure gauges were being made, that they just were set up a certain way so that when it rained, it would read a lower pressure, when in fact maybe it's not a lower pressure. You know what I'm saying? I'm not sure. I'm trying to find the answer to that. But anyway, thank you very much. Hope you enjoyed it.